future nurses, Professor Van Gregory here with our fourth video on introduction on how to do dimensional analysis. In this video, we're going to be talking about when you use the frequency in your problem. And I want you guys to remember the key fact here. You don't have to decide using your own brain. What you're going to use is the labels. So every time your problem in the order says the word day, meaning that the order is for the entire day, your answer must have either the word day or dose in it. You're going to determine that by looking at the question to see what it asks, whether it's asking for the milligrams or milliliters per day or per dose. And then you put that word in your answer. And then when you're trying to match your answers on the left side of the equal sign and the right side of the equal sign will determine whether you need to use the frequency or not. So I've posted an example problem in the description. So go ahead and take a look, and we're going to work through that problem to show you what I'm talking about. So in that problem, we have an order of 40 milligrams per kilogram per day divided Q6 hours. Okay, so we see the word day here, so it's going to trigger our mind to make sure we have day or dose in the answer. Our weight for this problem is 65 pounds. And the question asks us, how many milligrams are we going to give per dose? So our answer is going to be milligrams per dose. And that's the key right here. Having that word dose in the answer is going to then help us determine whether we need to use the frequency or not. So now you're going to do this problem just like we've practiced in the first three beginner videos. We're going to use our golden rules. If there's a weight, we're always going to start with the weight. So 65 pounds, we need to get rid of the pounds, but we don't have any pounds in our given information. So we're going to use our relative of kilograms. We know that 1 kilogram is equal to 2.2 pounds. Pounds goes on the bottom because we want it to cross cancel with the pounds on top with the 65 pounds. And now we need to get rid of kilograms. So for kilograms, we need kilograms on the bottom to cross cancel. We have kilograms in our order here, and we have to keep everything in the given information together. So we can't just omit day and leave it out of our problem. We need that day in the problem to help determine whether we're going to use that frequency or not. So now that we have our order in the problem, our kilograms cross cancel. And when we look at our labels, we have milligram on top and day on the bottom on the left side and milligram per dose on the right side. Those still don't match. So this is where the magic happens. Because we have day in our problem still, we have to get rid of it because it doesn't match. So we know that day needs to go on top. And now we're going to look at the frequency to determine how many doses we would give per day. In order to do that, you're going to take 24, because there's 24 hours in a day, divided by 6, because it's Q6 hours, every 6 hours, which would equal 4. So we know that there's 4 doses per day. Now the days cancel out. And when we look at our problem, the only labels we have left on the left-hand side of the equation is milligrams per dose. We look at our answer labels, milligrams per dose. That tells us our setup is complete and we can do the arithmetic. So in the arithmetic, we're going to multiply 65 times 40, divide by 2.2, divide by 4. That's going to give us 295.45. In the problem, it says we're going to round to the nearest tenth. So we're going to underline that 10th spot, look to the neighbor on the right. That number is 5 or greater, which means the number we underlined is going to go up by 1. So our answer is 295.5 milligrams per dose. Please make sure you like and subscribe so you're notified when I post new videos.